Alright, so the particle model of matter. If we look here, we've got our three different types of matter. So gas, they assume the shape and the volume of its container. The particles can move past one another. It's compressible. Lots of free space in between particles, as you can see there in the little picture, and they flow easily past one another and move in all directions. So they do not flow to the lowest possible level. They kind of fill the entire container. When we look at liquid there, it takes the shape of the part of the container in which it occupies. So this is where it was talking about how it makes its own surface or its own kind of area, right? So the particles move or slide past one another. It is not easily compressible. There's little free space between the particles, and it can be poured, always flowing to the lowest possible level, and the form of a level flat surface at the rest. So that's talking about how the surface of the liquid is always flat or level. Okay? And we compare that to a solid where it retains a fixed volume and shape. It's rigid, the particles vibrating in place. It is not easily compressible, and there's little free space between the particles, and they form a pile when they are poured. The particles do not continue to flow apart from each other. Alright? So those are really good little pictures of the different types of particles within these different types of states of matter. Now, we're going to talk about viscosity. Viscosity is a fluid's resistance to flow. So, fluids can flow. How quickly they flow is called their flow rate. A substance's resistance to flow, or how thick it is, or its viscosity, affects its flow rate. So, the internal resistance or friction between the particles of the substance determines the viscosity of that substance. So, the more friction or the more viscous or thicker a substance is, the higher the viscosity of the substance and the slower that it flows. So for example, ketchup has a high viscosity and we term it as thick, whereas soda pop has a low viscosity and we call it thin. Okay? Viscosity changes with temperature, so an increase in temperature decreases viscosity. Now looking at density, it is the amount of mass in a given volume. So in objects that are less dense than 1 gram per milliliter float on water. The Dead Sea is one of the saltiest bodies of water on Earth. When salt is added to water, there are more particles in a given volume, which increase the density of that water, allowing denser objects to float on the salt water. When we look at temperature and density, density does not change as long as the temperature remains the same. The particle model of matter states that every substance, the number of particles in a given volume, remain constant if the temperature is kept constant. As energy is added or heat, the particles move more quickly and further apart, thus increasing the substance's volume. When this happens, the density of the substance, which is its mass to volume ratio, decreases because the mass remains constant but the volume increases. One substance that can have different densities depending on what state it's in. Now if we look at buoyant force, buoyancy is the tendency of a substance to float. Buoyant objects take up a space in a fluid, pushing some of the fluid away or displacing it, causing them to float. This happens because the fluid pushes back against the force of gravity. So less dense objects float on more dense substances because of buoyant force. When an object is in a liquid, the force of gravity pulls it down, and the liquid itself has a force that acts against the force of gravity. This buoyant force pushes the object upwards. So objects that are more dense in water will sink, they have negative buoyancy, where objects that are less dense than water float, they have a positive buoyancy. Objects of the same density of the water will hover, and they'll have neutral buoyancy, and they are suspended, so neither sinking nor floating. Force is a push or a pull on an object, and it is measured in newtons. This is something that we looked in our past unit at. So the upward force of a fluid or on an object is called its buoyant force, which is also measured in newtons. And the calculation for buoyant force is buoyant force equals the weight of the object in the air minus the weight of it in its liquid. We're going to continue with buoyancy applications in the next video.